Okay, quick review. So the center is the very middle of the polygon. Okay. We just learned about something called an apothem, and the apothem starts where?
Awesome. Back midpoint.
From the center and goes
To the side.
to a side. And what's important about it?
Perpendicularly.
Perpendicular. Okay, so that's the apothem. Okay, a central angle. So real quick, I guess before we get to central angle, this polygon actually has something called a radius. Now, a lot of you probably remember the word radius from what?
Circles.
A circle, right? So let's say I have a circle. What is the radius of a circle? What does the radius look like? It's half of the diameter. Remember that word? So center to a side. We would call that the radius. Now, I thought only circles had radii. Why do you think this is actually called a radius?
Because it's half. It's not half.
But why is that different than the apothem?
Because it goes to an angle.
Because it goes to an angle. That's exactly right. So look at this. What happens if you take all the vertices and you make a circle out of them? Can you see how that the red line here actually touches the circle? But does the apothem?
No.
No. Can you see how the side of the polygon cuts it off and it doesn't quite get to the circle? So there's two segments you need to know about, an apothem and a radius, and you need to know the difference, okay? So a radius, actually two radii, create something called a central angle. This is called a central angle. How do you think they got that name?
It's in the middle.
It's at the center, right? It's the angle that's formed at the center with two radii. So how many central angles are there?
5.
There's 5, right? Because it's a pentagon. So how many vertices does it have?
5.
Yeah, so there's 5 radii, which means there's going to be 5 central angles. How many central angles would an octagon have?
8.
How many central angles would a dodecagon have?
12.
12. Okay. So how many degrees are in a full circle? 360. And how many central angles are in a pentagon?
5.
Divided by 5. So circle this right there. That's your formula. That's how you're going to find a central angle.
So,
My storage, you can take it from there.
so 360 is how many sides of the...
So what would the central angle degree be for a pentagon?
360 divided by 5. Oh my gosh.
Which is?
No, that's kidding.
72. 72 degrees.
Close.
Okay, so this one asks us to draw the apothems and then find the central angles. So I'm going to do the octagon together. It's got the 8 sides. I'm going to start by drawing a center of my octagon. And then I'm going to draw 2 radii.
1, 2.
You can draw all of them if you want, but we're just going to practice doing kind of one triangle in each of these.
Now, what is my central angle measured? How do I find it?
360 divided by 6. It's 45. How much?
45.
Divided by 8.
I don't know how many sides
45.
What are you doing?
Okay, 360 divided by 8 is
Enough.
45 degrees. Okay? And then you can draw in your apothem. It bisects our angle. So draw a perpendicular line from the center to the side.
So this is the...
The blue is the apothem.
Wait, I have a question.
Yep. What if I just wanted this little angle right here, this mustard yellow one?
Same thing as...
It doesn't look like
Oh,
the
wait,
same
no,
number.
that's half. If you cut it in half.
Yep, I just divide it by 2. So that little yellow angle would be about 22.5 degrees.
Wow.
Why do you think we would want to know that angle?
So the apothem takes a central angle and divides it by 2, but why do you think the apothem is helpful?
What I just drew in yellow.
Because it makes a right triangle.
It makes a right triangle, and we know a lot about right triangles. We just spent like forever on right triangles. So if we knew one part of it, we could find a different part using trig. Okay, let's try. What's our 6-sided figure called?
Hexagon.
It's a hexagon. So I'm going to draw in a central angle from the center to 2 radii. And what's that central angle going to measure to? 360 divided by 6. Oh my goodness.
360.
360 divided by 6, which is 60 degrees. Okay. Then we draw in our apothem. The right angle. And what would that yellow angle be? Be 30 degrees, which is half of the central angle. Try the other 3 on your own. Alright, so check your answers. Could have been any of them. You could have drawn any of the central angles or the apothems. Really? Now let's look at our pentagon.
Get it?
Our 5-sided one. Is every pentagon every regular pentagon gonna have the same central angle of 72 degrees?
Yeah.
Why?
Because they have 5 sides.
Because they have 5 sides and they are regular, so they're all similar. The similar shapes change the angle measure?
Nope.
Nope. So they stay the same. Okay. So this is kind of like that picture that Mr. Starks drew for us. So it's got our 6-sided shape. What's that? What's the name of it?
Oh,
Hexagon.
Let's practice naming real quick. What's the apothem in this picture?
Circle.
Remember, we name a segment with 2 points and a segment symbol over the top. So what is the apothem? GH.
You just said you name it with
So GH. Segment GH is the apothem. Okay. What about radius? So the radii, how many do we have drawn for us? 2. G, E, and GF. Okay. What is the angle? Remember, we name an angle with 3 points with the vertex in the middle. What is our central angle? It's angle EGF. What else could we call it?
FG.
Yeah, FGE. So those are kind of the 3 different vocab words we talked about. Radius, apothem, and central angle.
What's the circle called?
A circle.
The circle.
So A actually asks for that central angle. So how do we find central angles? Divided by the number of sides. So it's 60 degrees. We got that on the left side. Next, it asks for measure of angle EGH.
30.
So EGH is just half of that central
30.
angle. So it's going to be 30 degrees. And then the last angle it asks for is the last angle of that little triangle.
60.
How'd you get 60?
Because you add 30 and then 180 minus the 120.
Yep, so 180 minus the 90 minus the 30 that we had in the triangle, and it's left with 60 degrees. All of that was leading up to our area of a regular polygon formula. So this is on your sheet. You can circle it. The area of any regular polygon is equal to 1/2 times little a. What does little a stand for?
Apothem.
Apothem. Be careful, it's not area. Area is always going to be the big A. So 1/2 times the apothem times the perimeter. Alright, so this example is on your notes towards the bottom. So you're given a wooden coaster. It's a regular octagon. So that means all the sides and all the angles are congruent. And the sides are 3 centimeters. It's already been labeled for us. Okay? And then it's got a radius of about 3.92 centimeters.
How do I know that that's a radius and not the apothem?
It goes from point to point.
Good, it goes to a vertex, not perpendicular to the side.
So we're looking for the area of a coaster. So I'm going to go ahead and write that area formula down. 1/2 times the apothem times the perimeter.
Always write the formula down so you know what you're looking for. That way you can start brainstorming what do I need and how do I find it.
So I'm going to draw in the central angle. What's the total measure of the central angle? How do I find it?
360 divided by n.
And n in this case is 8. So it's going to be 45 degrees. And what we really need is just half of that, from the apothem to 1 radii. Okay. So we're just going to take that 45 degrees and divide it by 2. Get 22.5 degrees. Okay, so I'm going to take that little triangle and I'm going to redraw it so it's a little bigger. We got this triangle. Oh, I'm going to. So this was our apothem, little a. What was this angle measure? 22.5 is half of the central angle. And then how long was our radii? That would be this line. 3.92, it gave us that. So how can I find A? SOHCAHTOA. Yep, so we have a hypotenuse because it's right across from the right angle. And then our adjacent. Okay. So cosine of 22.5 equal to adjacent over hypotenuse. X is up high, so we need to multiply. So A is equal to 3.92 times cosine of 22.5. And we actually already know the side length. It gives us that. So what would be the perimeter?
18.
We have 8 sides and each are 3 centimeters.
24.
24. So our area is equal to 1/2 times our apothem, which was 3.6, times the perimeter of 24. So you should have gotten 43.2 centimeters squared. We're doing area, so it's a square unit. So what would the central angle of the triangle be? How do you find a central angle? 360 divided by the 3 sides, so our central angle is 120 degrees. And if I just wanted half of the angle, what would that be? That would just be a 60-degree triangle. So I'm going to draw that one over here, a little bigger. We have our right angle and our apothem. And then we have 60 degrees. And we're given that the radius is 6.
So could we use Pythagorean theorem this time
No.
to find A? No, because we don't know any of the sides of the triangle. So our only option is trigonometry.
So what kind of side is A? It's adjacent. And then what kind of side is 6? So I have an adjacent and a hypotenuse. I'm going to use cosine. So 60 degrees is equal to adjacent over hypotenuse. X is up high, so we need to multiply. What else do we need to know? To fill in our area formula. Our perimeter. We can find the perimeter by finding this side of our triangle. Let's call that X for now. So now that you have 2 sides, could you use Pythagorean theorem? You could. I'm going to keep it with Trey just to get extra practice. It's been a while. Okay, so I have, what kind of side is X?